Hi, welcome to my YouTube channel. In the last video we talked about rule of function of function, and we saw that if we have a function y equal to f of u, that means y a function of u, and also we have that u itself is a function of x. So if you have y f of u, then u h of x. If y is a function of u and u itself is a function of x, then if you want to differentiate y with respect to x, we have that dy dx is equal to dy over du multiplied by du over dx. Okay, and we gave this example that if you have y equal to sine x plus 3x and everything raised to power 3. Of course, the way to do this is to make everything in the bracket equal to u. Okay, everything inside the bracket equal to u. Then you differentiate y with respect to u, because now we'll be having y equal to u raised to power 3. This is what I mean. You let u equal to whatever is inside the bracket, sine x plus 3x. Then we now have y equal to u raised to power 3. Then you differentiate y with respect to u, which will be 3u squared. Then you now differentiate u with respect to x. Du over dx will be equal to, if you differentiate sine, we have cosine, right? If you differentiate 3x, we just have 3. Okay, then dy dx will just be simply multiplying this with this given by this equation. Then you substitute the value of u, which is sine x plus 3x. Also in the last video, I gave this problem, which is f of x equal to ln x all raised to power 2. Of course, ln is just logarithm of x raised base e, okay, where e is the Euler's number. So I actually to differentiate that with respect to x, which is f of x or dy over dx. Now it should be dy over dx if actually we say f of x is equal to y. Okay, it could be du over dx if f of x is equal to u. Okay, so, and I promise to drop the solution to this problem right in this video. Okay, of course, this is where I ask the question. It will pop up on the screen right now. Okay, all right, so the way to do this is just to let u equal to whatsoever that is inside the bracket, which is ln x. All right, so we differentiate that with respect to x. So du over dx, which will just be 1 over x. Okay, you remember that if you differentiate ln x, we have 1 over x. Then right now we just have f of x is equal to u raised to power 2, right? Okay, but now it's going to be f of u, because now it is a function of u. Okay, so we'll now differentiate this with respect to u. If I let this equal to y, then this will be equal to y equal to u squared. Then we differentiate that, which is dy over du. That will be 2u. Okay, all right. Then dy over dx will simply be dy over du times du over dx. Dy over du is just 2u. What is u? U is just ln x, right? 2u times 1 over x times 1 over x, which is simply 2 ln x over x. Okay, all right, that's it, 2 ln x over x. Okay, we also saw that in the last video we talked about higher order derivatives, and that if we have y a function of x, that the first derivative is represented with dy over dx, or f prime of x. Okay, the first derivative is represented with f prime of x, and the second derivative is represented with d squared y over dx squared, or f prime prime of x, telling you you are differentiating it for the second time. Okay, that is d squared y over dx squared. Now the fourth derivative will be d4 y over dx4. Okay, that will be f prime 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 of x. Okay, you are differentiating it the fourth time. Okay, I found it difficult to pronounce the word differentiating. Okay, bear with me. Okay, all right. So there was a mistake in the last video, which is this. Okay, all right. So it should have been 6 minus 30x, not 6 minus 3x. Okay, so this actually came from differentiating this function 3 times, which is d3y dx 3. Okay, all right. So this is an example that I gave in the last video, that if we have g of x equal to 3x minus 5 all raised to power 2, you should find the third derivative. All right, let's give this a try. All right, the first thing to do is just to let u equal to 3x raised to power 3 minus 5. Okay, then we now have of course, if we let this equal to y, then we now have y equal to, this is u already, so we have u raised to power 2. dy over du will be 2u. Okay, so du over dx will now be 9x squared minus just minus 0, or just 9x squared. Okay, then dy over dx is just multiplying these two. Okay, multiplying these two. So dy over du is just 2u. And what is u? This is u. 3x is 3x raised to power 3 minus 5. Then multiplied by 9x squared. Okay, so we just have to expand this first. We have 6, 2 times 3, 6 times 9, that's 54. X raised to power, this would be 3x raised to power 3 times x raised to power 2, that would be x raised to power 5. Okay, minus, this is 10, and that would be 90, x raised to power 2. Okay, so the first derivative, which is g prime of x, is just 54 x raised to power 5 minus 90 x raised to power 2. Then the second derivative, which is g prime prime of x, will be 5 times 4, that is 20. 5 times 5, 25, plus 2, 27. We have 270 x raised to power 4. Then minus 2 times 90 is 180x. So this will be g prime prime of x, which is the second derivative. And the third derivative, which is g prime 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 of x, will be 4 times 0. 0, 4 times 7, that will be 28. So we drop 8, carry 2. 4 times 2, 8. 8 plus 2, we have 10. Alright, x raised to power 3 minus 180. Let's be sure of this. 4 times 0, 0. 4 times 7, 28. 2. 8 carries 2. 4 times 8. Okay, that's it. So this is the third derivative of the question. Alright. I also drop this. Now if you have s equal to t 3t raised to power 4 minus t squared, now what is the third derivative with respect to t? Okay, so first let's find the first derivative, ds dt. That will just be 4 times 3, 12, t raised to power 3 minus 2t. This is the first derivative. Second derivative, ds squared, d squared s dt squared will be 3 times 12, which is 6, 3, 36, t raised to power 2 minus 2. Okay, then the third derivative, which is d3s ds3, or d cubed s dt cubed, will be equal to 36. So we have 12, 1, 672 t, and then minus 0, because differentiated constant we have 0, so we just have 72 t. So this is the third derivative of s equal to 3t raised to power 4 minus t squared. In the next video, we'll be looking at mixed rules. So we'll be looking at a situation where you have equation where you have to use product rule, sum rule, quotient rule, just a combination of those rules that we gave. All right, see you in the next video, and don't forget to like and share this video, and most especially subscribe if you haven't done that. All right, see you in the next video.